So in this lecture, we are discussing a method of a successive approximation known as a Picard's method. So we're starting with the initial value problem. So the initial value problem that is y dash is equal to f of xy, where f of xy is an arbitrary function of two variable x and y, and initially the condition is given is y of x0 is y0, where this f of xy is an arbitrary function. And this is defined in the neighborhood of x0, y0. So it is defined over the neighborhood of y0, and also it is continuous in the neighborhood of x0, y0. It is defined and continuous on the neighborhood of x0, y0. So our purpose is to devise the method of constructing a function y is equal to f of x or y is equal to y of x, whose graph passing through the point x0, y0 and satisfies this differential equation y dash is equal to f of xy in some neighborhood of f of xy. So we are interested to find out some graph of the function, which is this y is equal to y of x, which has to be passing through the point x0, y0, and it satisfy this initial condition as well as this differential equation. That is our objective into this things. To solve this differential equation means geometrically we have to find out some function y equal to f of xy or y equal to yx, which passing through this point x0, y0 and satisfying this differential equation. The method we described is furnish a line of attack of solving a differential equation, and that is quite different from the any other method which you come across. So here the method is to replacing the initial value problem, if I call it this is a problem 1, by equivalent integral equation. That is, if I can write down the integral equation y is equal to, so I can write down this equation, or in short I can write initial value problem 1 is equivalent to integral equation, that is y of x is equal to y0 plus x0 to x f of t into y of t, t y of t dt. How we can achieve this? This is we achieve by just fundamental theorem of calculus. If you integrate both sides on this equation 1, then this will be integration and the derivative of dy by dx, and since these are the limits is there, so I am just integrating from x0 to x0 to x, then you will have such thing, and by replacing this dummy variable t to dt, instead of x we are just writing t here. So this both this equation 1 and equation 2 are equivalent. So if I want to find out the solution for this one, it is equivalent to find out the solution for this integral equation. Now to get the solution of the integral equation, And one can easily show that, or I'm just starting with one initial solution, that is y0. Okay, so in order to obtain the new solution or better approximation as y1 of what we have here, we'll write y1 of x is equal to y0 plus integration x0 to x f of t comma y0 dt. So in the next step is to generate a solution, or to generate a solution, or use y1 to generate another solution. So in the next step, use y1 of x to generate another and better approximation. In the same manner, so instead of y0, now we replace y1. So y2 of x, that we will get is y0 plus x0 to x f of t y1 of t dt. And if you continue in this manner, at the nth stage, we will have at the nth stage of process, we have yn of x is equal to y0 plus x0 to x f of t y n minus 1 of t dt. And this procedure, it's called the Picard's method of approximation, successive approximation. So this is known as a Picard's method of successive approximation, and we saw how it worked by solving some examples here. So I'm just taking the first example, that is, find approximate solution of y dash is equal to y, where y of 0 equal to 1. See, first of all, you just observe that what will be the solution for this differential equation, or I can say initial value problem. Why it is initial? Because initially it is given as a value. And we know that by separable variable method, one can solve this. This is dy by y equal to dx. So this is log y equal to x plus c. So that is y equal to e power x into a. And if you use this condition, y of 0 equal to 1, which implies 1 equal to a. And so the solution for this differential equation is y equal to e power x. So this is the solution. But here our objective is to calculate the approximate solution. As per this Picard successive approximation method, we'll start with the initial solution, which will be y of x is equal to y0 integration. What is x0 and y0? Here in this case, x0 is 0 and y0 is 1, because of this is x0 is there and this is y0 is there. So as per this, the equivalent integral equation, what we have, as per this is y of x is equal to y0 plus summation integration x0 to x f of x0 or t y of t dt. This is the things which we have, the equivalent integral equation which we have, equation 2, we have write in the form of equation 2. And the y0 we know it is 1 plus x0 is 0 to x, and f of x y, here it is a function y. This is your f of x y. So it is y of t dt. This is your y of x. Now initially we'll have this, or by method of successive approximation, so by method of successive or by method of approximation, yn of x will be 1 plus integration from 0 to x yn minus 1 of t dt, which we have got from the last successive approximation formula. Yn is equal to y0. Instead of n, we can substitute that. Now, what we'll have, y0 of x is 1, which is initially given, y0 is 1, that we have given here, y0 is 1. So that is y0 of x is 1. Initially we have this. So with this y0 of x is 1. So therefore now y1 of x is 1 plus integration 0 to x. So instead of y0, if we can replace this n equal to 1 in this equation, this is y1x is 1 plus 0 to x, y0 is 1 dx. So this is 1 plus x. Integration of 1 is x, and if you put the limit 0 to x, we'll have 1 plus x. Second equation, that is y2 is 1 plus integration 0 to x, 1 plus x dx. That is 1 plus x square by 2. y3 of x will be 1 plus 0 to x, 1 plus t square by 2 dt. If you integrate this one, this will gives you 1 plus x square by 2 factor 2 and x cube by 3 factorial, because this is 3 by 3, 2 into 3 is 3 factorial. And in general, if you can go further, in general, we'll have yn of x is 1 plus x square by 2 factorial up to so on, x raised to n upon n factorial. And if we can take this n tending to infinity,
Sir,
that is
sir, in y2 of x, we have to integrate with respect to t.
t and x are dummy variable.
Okay.
See, this is, if you can write t, then there is also no problem, because the integration of 1 plus, this is t plus t square by 2, and if you put the limit 0 to x, this is x square by 2. So exactly the same thing we have. It is a dummy variable. Instead of that, I can write x also. That also no change is there.
Okay, sir.
Okay. So k running from 1 to n, x power k upon k factorial. If I take n tending to infinity, then we know that this is exactly the power series of, so as n tends to infinity, the y of x, that is the solution of equation, will be x power k upon k factorial. That is exactly e power x. So this is the approximate solution for given differential equation, or I can say this partial sum of this past power series of, this is the partial sum of the power series of e power x that we have. Let us solve another example. Consider this equation. That is y dash is equal to x plus y of 0 equal to 1. The solution also I am just giving you as a homework that you can find out the actual solution for this. Here my interest is to find out the approximate solution for that. So here x0 is 1, sorry, x0 is 0, y0 is 1, f of xy we have it is x plus y. This is the things we have given. So as per this equivalent, writing this equivalent integral equation, is y of x is equal to y0 plus integration x0 to x f of t y of t dt. So as per this one, this is y0 is 1, so it is 1 plus 0 to x. This is t plus y, so this is, sorry, x plus y, so it is t plus y of t dt. And the approximation is y of n x is 1 plus 0 to x t plus y n minus 1 of t dt. This is the approximation we have. Now if you replace this, or we have this y0 is 1, if we substitute y at n equal to 1, now by Picard's method, we have y1 of x will be 1 plus 0 to x t plus, this is y0 we have already 1, so it is t plus 1 dt. If you integrate this one, this is 1 plus t square by 2 plus t limit 0 to x, so it is 1 plus x square by 2 factorial I can write. And y2 of x will be 1 plus 0 to x t plus this quantity, that is 1 plus t square by 2 factorial dt equal to 1 plus integration 0 to x 1 plus 2t plus t square by 2 factorial dt. And if you integrate this, this is 1 plus t plus 2t square by 2 plus t cube by 3 factorial. And if you put the limit 0 to x, then this will be 1 plus x square plus x cube by 3 factorial. And so on. If you can calculate your y3 by yourself, I am giving you time to calculate y3 and y4. So please find out what is y3 and y4. What is the value of y3? So as per this, it is 1 plus integration 0 to x 1 plus 2t. Why? Because it is t plus, so that t, okay, let me do it one step here. So this is t plus y of t, that is this 1 plus t plus t square plus t cube by 3 factorial dt. Integrate this one, This is 1 plus t plus this t plus t is 2t, so it is 2t square by 2 plus t cube by 3 factorial, sorry 3 t cube by 3 plus t raised to 4 by 4 factorial. And the limit is 0 to x. So finally you will have 1 plus x square plus x cube by 3 plus x power 4 by 4 factorial. Similarly, if you can see that this will be 0 to x, 1 plus 2t plus t square plus t cube by 3 plus t raised to 4 by 4 factorial dt. This will gives you 1 plus x square plus x cube by 3 plus x raised to 4 by 3 into 4 plus x raised to 5 by 5 factorial. So this is the way you can have the approximate solution, or in general we will have a solution, that is yn of x will be 1 plus x plus 2 times 1 plus x is there plus 2 times x square by 2 factorial, x cube by 3 factorial, x raised to n by n factorial, because this is, you just multiply and divide by 2 here. That's why this will be, if I can multiply and divide by 2 in this 3 terms, that is x square by 2 factorial, this is 2 into 3, so it is 2 3 factorial, 2 into 3 into 4, so it is 4 factorial, and plus this x power 5 upon n factorial is already there. So this is the things we have, and if I can take this n tending to infinitive, then this series is actually converged to, so this eventually, can anybody tell me where it is converged to? First of all, 1 plus x is there plus 2 times, what is this, where this will converge? This will converge to e power x, because the first 2 terms of e power x is not there, so I am subtracting that, that is minus x minus 1, plus this will converge to 0 as n tends to infinity, because your x is between, in the neighborhood of 0, 1, that is the, so it is in the neighborhood of 0, this x is in the neighborhood of 0, so this quantity will tends to 0. So finally you will have, this is 2 e power x, then x minus, so it is minus x minus 1, so it is converged to this function. So the solution of above equation that we have, it is e power 2 times e power x minus x into minus 1, or approximate solution will be this one. So this is regarding the Picard's method, and this Picard's method is the used to calculate or to derive the existence and uniqueness theorem of the differential equation, that we will discuss later on. You have any questions?